Hey everyone, in this video we're going to look at the second part of lesson 2. So you were supposed to try these practice problems on your own this page. Hopefully you did that, but now we're just going to kind of compare our answers. So in number 2, a group of students at a high school took a standardized test. The number of students who passed or failed the exam is broken down by gender in the following table. Determine whether gender and passing the test are independent, rounding all probabilities to the nearest thousandth. So the first thing I would do in this case is get your totals. So the total amount of students who passed is going to be 125. Total amount of students who fail are going to be 102. The total amount of males who took this test would be 158, while the total amount of females would be 69. And when I add either of these totals up, I would end up with 227. So you need those totals just to help you out. So if you want to write something like total on the side here, you can, but it's really just a note for yourself, especially if you're going to do it the way that we were talking about in lesson 4. So we're looking at gender and trying to determine if gender and passing are independent. So remember the way we looked at it in this lesson. Now I know I've done male in the past, so I'm going to switch it up to female here. So the probability of being a female times the probability of passing would be independent if the probability of being a female and passing is equal to this here. So remember, your probability of being female is 69 out of the 227 participants times the probability of passing would have been 125 out of 227. Now the and comes strictly from this spot where female and passing meet. So we're doing 4 out of the 227. And then we let the calculator do the work for us, right? We take 69 divided by 227. We times that with 125 divided by 227. And we get to the nearest thousandth again. We're looking at 0.169. Actually, we have 1696, so that's going to be 0.17. Now, we look at 4 divided by 227. And we end up with 0.018. The two are not equal to each other. And this is a test of independence, so they are not independent events. Okay, if they were independent, they would have been equal to each other. So not independent for us there. For 3, we also have to fill in this table. So they just did it in a little bit of a different style. So to do so, I'm going to take 76 and I'm going to subtract 28 to find the amount that take vitamins. And when we do that, we end up with 48. Now, 48 plus some number gets me 60, so I could do 60 subtract the 48. So we're looking at 12 here. And I could do 12 plus 32, and we would get 54 as the no regular exercise group, and that checks out for our totals because 76 plus 54 does in fact, I actually wanted 44 here, not 54. That's why I double checked that 76 plus 44 is equal to 120. That would not have worked with the 50. And then finally, on the bottom here, we would have a 60. So that's the first part, just to fill in the missing table. Now, determine whether a patient who takes vitamins and a patient who exercises regularly are independent events. So, using the method we've already practiced here, we know we can do probability of taking vitamins times the probability of exercising regularly. It should be equal to the probability of both of those things. So in our case, taking vitamins is 60 over 120 times the regular exercise is 76 over 120. The probability of both of those happening meets at 48 out of 120. So again, this is all calculator work. You're looking at 60 divided by 120 times 76 divided by 120. And when I do that, we end up with 0.136 repeating. When we look at 48 divided by 120 for the right side, we get 0.4. Unfortunately, they are not equal, so they are not independent. So just to recap now from lessons 3 and 4, this lesson, there were 2 ways to test independence. One way is to do what we were doing here, the probability of a given event A times the probability of the given event B. If they multiply together to get the probability of A and B, remember this is our and sign, then they are independent. So that was the one way, what we're doing today. The first way we learned about, though, is with our given. So the probability of A given B is equal to the probability of A. So that basically says that given has no effect of our outcome. And remember, the given is when you have probability of A and B, given B, so we know B had to happen, and it still equals the probability of A. And either of these, it can be vice versa, like you can switch it to B given A, you just would switch all those pieces. But yeah, so those are your 2 different kind of ways of testing your independence idea. One last idea for us here is if we have Sean's team has a baseball game tomorrow, he pitches 50% of the games, there is a 40% chance of rain during the game tomorrow. If the probability that it rains, given that Sean pitches, is 40%, it can be concluded that these 2 events are blank. Well, so let's think here. We have our magic word given. So the probability that it rains given Sean pitches, well, that's equal to 40%. So I'm just going to call it 0.4. The probability of it raining is equal to 0.40 as well. The probability of him pitching is equal to 0.5 or 0.50. Okay, so out of those, the one I see that kind of stands out to most to me here is these 2 here are the same. So think about it like this. The probability of it rain given he pitches is equal to the probability of it raining. So that being said, these 2 events are independent of each other. So we saw that test right in there. Okay, dependent is if those 2 were not equal to each other. Mutually exclusive is if there's no overlap whatsoever, right? So there couldn't be a given. Okay, so mutually exclusive refers to when I'm looking at my Venn diagram, if there's nothing that can be the overlap, so if there's nothing that can, like if this is the case, then the probability of it raining given he pitches, there's no way that could happen with mutually exclusive. There's no overlap when it's mutually exclusive. And complements add up to 1. So if we had like a 0.4 and a 0.6, those, but also the complements, remember, they also don't have anything that overlaps, because a complement, it would be Sean pitches,